Hello friends, welcome to our channel Anand Academy of Education. We are discussing theory of equations. Theory of equations. This is our second lecture, and in the last lecture we had seen the definition of an equation, what is not an equation, the different standard forms of linear equations and quadratic equations. And now in this lecture we will discuss nature of roots of a quadratic equation. Nature of roots of a quadratic equation. Okay, let's get started. So what is a root of an equation? Before going to the nature of roots of a quadratic equation, let us first see the definition of root of an equation. So what is the meaning of root of an equation? So this root is also called solution. So root of an equation or solution of an equation, both are same. So what is root? It is a value of a variable or variables which, when substituted in the place of variable, or variables, the given equation holds true. The given equation holds true. So what does that mean? So root is a number or value of a variable which, when substituted in the place of the variable, the given equation holds true. This means that when we substitute that value or number in the place of the variables in the given equation, then that given equation holds true. The given equation holds true. So when does the given equation holds true? When we substitute some specific values or specific numbers, and we call those specific numbers roots. So when we substitute those roots in the place of the variables in the given equation, then the given equation holds true. Let us take an example so that you will get a clear picture. So let us take x square is equal to 9. So what is the value of x, or what are the values of x such that x square is equal to 9? So those values are x is equal to plus 3 or x is equal to minus 3. So if we substitute plus 3 in the place of this variable x, then it becomes 3 square, which is 9. So this equation holds true. Likewise, if we substitute minus 3 in the place of this variable x, which is minus 3 whole square, is also 9. So we can say that these two are the roots of this equation x square is equal to 9, because when we substitute these two values in the place of this variable x, this equation holds true. And so we call these two numbers as roots of this equation. Let us take another example. If we take 2x is equal to 1. So what is the root of this equation? The root of this equation is x is equal to 1 by 2. Because when we substitute 1 by 2 in the place of this variable x, 2 into 1 by 2, it becomes 1. So the equation holds true when we substitute 1 by 2 in the place of x. So we can say that 1 by 2 is the root of this equation. So this equation has a single root. This is single root. Whereas this equation has double root or two roots. This equation has two roots. Likewise, a cubic equation can have three roots, can have maximum of three roots. And an equation raised to the power of 4, will be having a maximum of 4 roots. So, root is some specific value of a variable which, when substituted in the place of that variable, the given equation holds true. Now let us see the roots of a quadratic equation. The standard form of quadratic equation is x squared plus bx plus c is equal to 0. X squared plus bx plus c is equal to 0. So let us consider alpha and beta as roots of this equation. Let us consider alpha and beta as the roots of this equation. So this implies that when we substitute this root alpha in the place of these variables, this equation holds true. This implies a alpha square plus b alpha plus c must be equal to 0, since alpha is root of this equation. Likewise, a beta square plus b beta plus c must be equal to 0, because beta is also root of this equation. And we have a formula for finding the roots of a quadratic equation. That formula is, the roots alpha and beta are given by this formula: minus b plus or minus root of b square minus 4ac by 2a. So this is the formula for finding the roots of any quadratic equation. So alpha is, one root is minus b plus root of b square minus 4ac by 2a, and the other root is beta is equal to minus b minus root of b square minus 4ac by 2a. So these two are the roots of the quadratic equation. So the roots of the quadratic equation are given by this formula. So the one root is this one and the other root is this one. And this b square minus 4ac is called discriminant. And this is denoted by delta or sometimes by d. Sometimes we denote this b square minus 4ac discriminant as delta or sometimes as d. So let us take a quadratic equation: x square minus 2x plus 1 is equal to 0. So what are the roots of this quadratic equation? We have this formula: a is 1, b is minus 2, c is 1, and we have minus b plus or minus root of b square minus 4ac by 2a. So this implies minus of minus 2 plus or minus root of minus 2 whole square minus 4 into 1 by 2 into 1. So this implies 2 plus or minus 2 square minus 2 whole square is 4. 4 minus 4 is 0 by 2. This implies 2 by 2. This is 1. So the only root of this equation is this one, 1. So 1 is the root of this equation. 1 is the only root of this equation. 1 is the only root of this equation. The quadratic equation can have a maximum of 2 roots. can have a maximum of 2 roots. Nature of roots of an equation. Nature of roots of an equation. So the nature of roots of a quadratic equation are determined by the value of discriminant b square minus 4ac. So this is often denoted by delta. So if the discriminant is less than 0, if the discriminant is less than 0, the equation has complex roots minus b plus or minus root of b square minus 4ac by 2a. So if b square minus 4ac is negative, then root of a negative number is a complex number. Root of a negative number is a complex number, and so the two roots will be complex. And a small request, if you don't know the differences between complex numbers, real numbers, rational numbers, and irrational numbers, I request you to watch our video on mathematic basics. So please watch that video if you don't know the basic concepts of complex numbers, real numbers, rational numbers, and irrational numbers. You'll get a better idea after watching that video. So if discriminant is less than 0, the equation has complex roots. Likewise, if discriminant is greater than 0, if this discriminant is greater than 0, the roots will be real. And distinct, two different. Minus b plus root of b square minus 4ac by 2a, and the other will be minus b minus root of b square minus 4ac by 2a. So these two will be different, two different roots and real roots. If delta is equal to 0, so if this delta is equal to 0, then this whole term would be 0, and minus b by 2a will be the only root. So in that case we say equal roots. If delta is equal to 0, the equation will have real and equal roots. So the fourth point is the conclusion of 2 and 3. This fourth point is the conclusion of 2 and 3. If delta is greater than or equal to 0, if delta is greater than or equal to 0, the equation has real roots. Isn't it? You can just look at these two real roots. If delta is greater than or equal to 0, the equation will have real roots. Likewise, if delta is a perfect square, if delta is a equation has rational roots, the equation has rational roots. So what is a perfect square? Perfect squares are numbers like 4, 9, 16, 25, 36, 49, etc. So these numbers are products of their multiples which are same. So 4 is 2 into 2, 9 is 3 into 3, 16 is 4 into 4, 25 is 5 into 5. So these are products of same numbers. So perfect squares are products of same numbers. So if delta is a perfect square, so if b square minus 4ac is a perfect square, then root of a perfect square will be rational. And so this minus b plus or minus root of b square minus 4ac by 2a, the two roots will be rational. But if delta is not a perfect square, then the equation will have irrational roots, isn't it? B square minus 4ac is irrational. This implies root of b square minus 4ac is irrational. So if this is irrational, then minus b plus or minus root of b square minus 4ac by 2a will also be irrational. This will also be irrational. Likewise, if p plus iq is one root of a quadratic equation, then p minus iq will be its other root. And if p minus iq is one root, p plus iq is the other root. Likewise, if p plus root q is one root of a quadratic equation, then p minus iq will be the other root. So this is the nature of roots of a quadratic equation. The nature of roots of a quadratic equation are dependent on the value of discriminant. The value of discriminant. So the roots will be different. The roots will be different and will be lying in different intervals based upon the value of discriminant. Based upon the value of discriminant. So when in examination, if they ask about the nature of roots, so what we need to do is to find the interval in which the roots of the given quadratic equation will lie. And we will be finding the nature of roots of the quadratic equation based upon the value of discriminant. Based upon the value of discriminant. So now, in the earlier slide it was a little messy. Now let us look at the nature of roots in a very simple manner. So nature of roots is dependent on delta. So we have two possible scenarios. When delta is greater than or equal to 0, when delta is less than 0. So when delta is less than 0, it is simple. The roots will be complex. The roots will be complex. But if delta is greater than or equal to 0, roots will be real. Roots will be real. Now we again have two scenarios. Delta is greater than 0 and delta is equal to 0. So when delta is equal to 0, roots are real and equal. Roots are real and equal. When delta is greater than 0, real and distinct. Real and two different roots. Here we have two possible scenarios. When delta is rational, delta is a rational number, and when delta is irrational, delta is irrational. If delta is rational, roots will be rational, and if delta is irrational, roots will be irrational. So this is the simplified figure. This is, remember the nature of roots using this in a very easy manner. So now some more important points that we need to remember in order to solve the questions in the examination easily without taking much time. If d1 and d2 are discriminants of two quadratic equations, so let us consider a1x square plus b1x plus c1 is equal to 0 is one quadratic equation, and a2y square plus b2y plus c2 is equal to 0. This is the second quadratic equation. Now d1 and d2 are discriminants of two quadratic equations. So let us consider the discriminant. The discriminant of equation 1 is d1 and discriminant of equation 2 is d2. So d1 and d2 are discriminants of two quadratic equations. Then if d1 plus d2 is greater than or equal to 0, if d1 plus d2 is greater than or equal to 0, the first one, at least one of d1 and d2 must be greater than or equal to 0. At least one of d1 and d2 must be greater than or equal to 0. Let us take d1 as minus 1. For example, let us take d1 as minus 1 and we need to find the value of d2. We need to find the value of d2. So for this sum to be greater than or equal to 0, then d2 must be greater than or equal to 1. d2 must be greater than or equal to 1. So which is greater than or equal to 0? So which is greater than or equal to 0? So for any numbers of d1 or for any numbers of d2, if d1 plus d2 must be greater than or equal to 0, then at least one of d1 and d2 must be greater than or equal to 0. At least one of d1 and d2 must be greater than or equal to 0. Likewise, if d1 is less than 0, here d1 is less than 0, then d2 must be greater than 0. d2 must be greater than 0. So here d2 is greater than 0. Likewise, if d2 is less than 0, then d1 must be greater than 0. If d1 plus d2 is less than 0, if d1 plus d2 is less than 0, then at least one of d1 and d2 must be less than 0. At least one of d1 and d2 must be less than 0. And if d1 is less than 0, this is same points. 2x plus 1 is equal to 0. Here a is 1, b is minus 2, b plus c, it is 0. If we add a plus b plus c, it is 0. A plus b plus c is 0. So let us try to put the value, put the number 1 in the place of this variable x. So if we 1 square 2 into 1 plus 1 is equal to 0. So when we put the value 1 in the place of the variables, what we have got is 0 is equal to 0. This implies that 1 is the root of this equation. 1 is the root of this equation. So we can say that if a plus b plus c is equal to 0 for any quadratic equation, if a plus b plus c is equal to 0 and a, b, c are rational, the roots of the equation will be rational and 1 will be one of the two roots of the equation. Here we have equal roots. But if we take another example, let us take another example. 2x square minus 1, 2x square minus 1, sorry, minus x minus 1 is equal to 0. 2x square minus x minus 1 equal to 0. Now let us take another example, because this is 2x square minus x minus 1 and x square minus 2x plus 1 will be having same equal roots. Now let us take another example. 3x square minus 2x minus 1 is equal to 0. 3x square minus 2x minus 1 is equal to 0. So what are the roots of this equation? So here a plus b plus c is equal to 0. So let us try to substitute 1 in this equation. So when we substitute 1 in this equation holds true. This equation holds true. So 1 is the root of this equation. Let us see the other root. So roots alpha comma beta is equal to minus b, 2 plus or minus root of b square, 4 minus 4 into 3 into 1, which is 12 by 2 into 3, 6. This implies 2 plus or minus 4 by 6. That is equal to 6 by 6 is one root and minus 2 by 6 is the other root. So this is 1 and minus 1 by 3. So these two roots are rational and 1 is the one of the two roots. 1 is the one of the two roots. So this is a very important concept. If a plus b plus c is equal to 0, a, b, c are rational, then 1 will be one of the two roots of the equation. 1 will be one of the two roots of the equation. So this is it for this lecture, and in the next lecture we will be coming with another topic. And thank you for listening.